right, so we are starting with galvanometer conversion. All right. Celebrity, how was your day today? Obunna, you're welcome. Okay, so today we're looking at galvanometer conversions. How we convert galvanometer to ammeter and also galvanometer to voltmeter. Okay, so please give it a thumbs up. Okay, let's proceed. I'm fine. How is your sister? She's not here. All right, so let's just go straight to the point while we wait for the rest of us to come. Okay, now before we proceed, I need to explain what is a galvanometer and what it is meant for or what is it used for. Okay, galvanometer is a device that we use to measure the amount of current, but then it measures very small amounts of current. So it measures in milliamperes. Okay, so we can compare it with ammeter. Ammeter measures in what? In amperes. So just like galvanometer measures from 0.01. Okay, 0.001. So you see very, very what? Small. So we want to know the situation, we want to see the situation whereby this galvanometer that measures very minute current will not make it to measure what? In ammeter. So that is just like doing the work of what ammeter can do, because ammeter measures a whole number which is from 1 to 10 amperes, right? While galvanometer measures from 0.001 to 0.009, as the case may be. Do you understand? So that's what we are doing. So how do we convert this galvanometer that measures very small current to start doing what ammeter can do? So that is what the topic is all about. Okay, we have it in two ways: conversion of galvanometer to ammeter and also conversion of galvanometer to what? A voltmeter. So I'm going to start with the first one. I hope you understand the introductory part I gave you. Galvanometer measures very small current, and we want to see a situation whereby we can make it to start doing what an ammeter can do. So the first part is what? Conversion of a galvanometer to an ammeter. That is the first part. Okay, so here we're using an instrument called what? Shunt. Let me just write it down so I can explain from there. We can convert a galvanometer to an ammeter by connecting suitable resistor in parallel All right, so let's go. We can convert a galvanometer to an ammeter by connecting a suitable resistor in parallel with the galvanometer. Okay. All right, so let's proceed. Now, a resistor used for this purpose, a resistor used for this purpose is known as a shunt. Okay. The shunt is a low resistance wire. And is used, let me just write it. All right, so let's look at that statement there. Let me explain before we proceed. He said, how can we convert a galvanometer to an ammeter? JAMB can ask you this as an objective question, okay? So we can actually do that by connecting a suitable resistor in parallel with a galvanometer. The resistor that we use for this purpose is called what? Shunt. Very, very important. The shunt is a low resistance wire, and it is used to divert a large part of the current being measured, but to allow only a small amount of current to flow through the galvanometer. Now, one word that is important that you should note in this statement is that for us to convert a galvanometer to an ammeter, we use a low resistance wire called what? Shunt. And it must be connected in parallel. Very, very important. You must note. It must be connected in what? In parallel. So, must be in parallel. And it is a low resistance wire. It is a low resistance wire. And the name is what? Shunt. Please, these things I'm underlining, very, very important. Check your JAMB past questions, you're going to see them there. For you to convert a galvanometer to an ammeter, we use a low resistance wire called what? Shunt. And it must be connected in what? In parallel. Very, very important. And the purpose of this shunt is to do what? To divert a large part of the current being measured, but to allow only a small amount of current to flow through the galvanometer. In this case, galvanometer will start working like what? To an ammeter. So if you are done with the write-up, let me do a sketch to explain further. Please, are we done? Okay. Are we done, please? So we can proceed. Are we done, guys? So we can proceed. This Achidera, are you done? Celebrity, are you done? Amarachi, are you done? All right. So let's proceed. All right, so let's proceed. We have a diagram like this. All right, now look at the diagram now. Look at the diagram. Let me just explain the diagram. Oh, network. Maruchi, okay. Okay. The camera is blurry, I don't know. Is it better now? Is it better? Is it better now? The camera, is it okay? You can see clearly now. All right, so let's proceed. Now look at it now. This is a current flowing in this particular circuit. Okay. Now this is a galvanometer. This is a shunt. This is a low resistance wire. And I said, for us to make this galvanometer now to start doing the work of ammeter is only when we connect this low resistance wire called what? Shunt. And it must be in parallel. Look at it, it must be what? In parallel. Okay. Now the current flowing through this circuit, when it comes to this part, it's going to split. I see it now. It's going to split. Then a little amount of current will flow through the galvanometer, while the rest of them will go to the what? To the shunt. That is the only way this galvanometer can start doing the work of what? Ammeter. Now we can go looking at the PD because they are connected in parallel. Remember, I did yesterday. When cells are connected in parallel, it becomes what? Equal. Remember that what we did yesterday. This is a cell, this is a cell, this is a cell, right? They are connected in parallel. So we have this, we have this, right? So this is E1, E2, and E3. They are what? Equal. Because all the positive terminals, they come to a central point called what? A. All the negative terminals come to a central point called what? B. So they are acting as if it's just one cell. Okay, so the EMF in the cell 1 is equal to EMF in the what? Cell 2. So that is applicable to this. The PD that flows in this galvanometer and the shunt, they are what? They are equal. They are what? They are equal because they are connected in parallel. So I will say PD across galvanometer is equals to PD across shunt. Are we following? From what we did yesterday, the PD across galvanometer equals PD across what? Shunt. What is PD? That is V. V across galvanometer equals to what? V across shunt. Do you understand? But V is potential difference. From Ohm's law, V is equals to what? IR. Are we there? V is equals to what? IR. So we can say that the voltage here or the PD here becomes what? IG RG is equals to what? IS RX. Do we understand? Are we cleared now? All right. So what is IG? This is current across the galvanometer, resistance of the galvanometer, right? Current of the shunt, resistance of the shunt. Okay? But there is one thing we must note. How do we know the current flowing through the shunt? If the total current flowing through this circuit is I, and from this I, the galvanometer has taken his own part, which one is remaining? That is current of the shunt. So for instance, if the current flowing through this circuit, let me assume it is 2 amperes, right? Out of the 2 amperes, the only thing that this galvanometer can measure is 50 milliamperes. Do you get it now? 50 milliamperes. You are going to remove this 50 milliamperes from these 2 amperes here. So the remaining current will now go to the shunt. That is what I mean by that. Okay? So let me say the current of the galvanometer is 50 milliamperes. What is milli? You divide by 1000, right? So this is 50 over 1000, right? This cancel this. That gives me 0.05 amperes. So this is the current flowing through the galvanometer. If I take it away from here, the remaining one will now flow through the shunt. So the current of the shunt, that is Ix, is equal to the total current minus current of what? The galvanometer. Am I making myself clear? All right. So that would be 2 minus 0.05. That will give me 1.95 amperes. This is the current that is going to the shunt. Are we cleared? Because the amount of current that is being measured in the galvanometer is going to be taken away from the total current flowing in this circuit. Remember, the current will split from here because they are connected in parallel. Okay, this one will go to the shunt, this will go to the galvanometer. So for me to know the current flowing to the galvanometer, I'm going to do what? I'm going to subtract the current of the galvanometer from here. Then the remaining one will be kept what? To the shunt. So I can say that the current of the shunt, Ix, is equal to the total current minus current of the galvanometer. I don't know if you have any question. Do we have question, guys? Do we have question? All right. Is it still blurring? Is it better now? Maruchi, is it cleared now? Shall I repeat myself? Helen, please, what's your name? Let me address you by your name, please. What's your name, Helen? All right, so Helen, what's your name? Is that right? So, Amarachi Kenneth, do you have question? Any question, please indicate. Let's know what you are doing. Yes, what if we're given the current of the shunt? Yes, I think I have a question like that. So we can actually solve it. Okay. So depending how the question comes, we can attempt the question. All right. If you understand the concept, what I just explained now, we can now start solving problems from JAMB past question. Okay, let me re-explain. All right, so let me explain it again. I said that this galvanometer is doing the work of what? Ammeter. Only if we connect a low resistance wire called shunt, which must be connected in parallel with the galvanometer. You can see it now. Okay? Must be connected in parallel with the galvanometer. So what is the work of the shunt? Is to allow a small amount of current to flow to this galvanometer, and the large part of it will now come to the shunt. Okay? And I said I gave an instance. Like now, current is flowing, coming to this point, there's a split. Some is going to the what? A large part of it is going to the shunt, while a small amount is going to the galvanometer. Okay, and I gave an instance that let's assume that the current flowing in the circuit is given as 2 amperes. Okay, and the amount of current that this galvanometer can only measure is 50 milliamperes. What are we going to do? What is the current flowing to the shunt? You can only know the current flowing to the shunt if you take away this 50 milliamperes from the 2 amperes here given the circuit. We cannot know the remaining one that's going to the shunt. Is it clear? All right. So, and I said that current of the galvanometer is Ig, right? Then it's equals to 50 milliamperes. That milli means divide by 1000 because milli is 10 power minus 3. So we now say this is what? 50 divided by 1000 gave us 0.05. This is the current flowing in the galvanometer. For us to know the current flowing in the shunt, we're going to say what? Ix, which is current of the shunt, is equal to the total current minus the current flowing in the what? Galvanometer, which is 2 minus 0.05. It gave us 1.95 amperes. Is it clear? So remember that I'm using the formula of what we did yesterday, current electricity. That if you're calculating PD or EMF of a cell and they are in series, the cells are in series, you're going to say what? That the total PD here is equal to total PD in the second cell. So the same way, the PD here in the galvanometer equals the PD across what? Shunt. That is what I have. VG equals what? Vx. And from Ohm's law, what is PD? Equals Ig Rg equals Ix Rx. Now, how do you know the current of the shunt? That is 1 minus current of the galvanometer. The total current minus current of the galvanometer. I think that's all. So let's all see some questions so far. Please copy it fast. Let's solve problem. Are we done, please? Are we done, please? All right, so let's proceed with the question. Okay. A 0 to 10 milliampere galvanometer with a coil of resistance All right. Question says a 0 to 10 milliampere galvanometer with a coil resistance of 30 ohms can be converted to a 0 to 10 amperes by using dash. So I have the following options. Option A, I have 0.03 ohm series resistor. I have 0.03 ohm shunt resistor. I have 9.99 ohm shunt resistor. I have 9.99 ohms series resistor. Now you can see the question now and see what we can solve to do this. Look at it. We have a galvanometer that ranges from 0 to 10 milliamperes, okay? But it has a coil of resistance of 30 ohms. How can we now convert this galvanometer to start doing the work of ammeter, which is given as 10 amperes? Okay, so we have to solve and get our answer in the options provided. So before we solve, guys, let's look at parameters. Let me say solution. Okay, the current of the galvanometer is 10 milliamperes. Forget about this 0. This is what we are using, okay? So forget about that 0, okay? So I'll say current of the galvanometer is 10 milliamperes. Remember what this milli means. That is 10 divided by what? Divided by 1000, okay? So this is 10 divided by 1000. We cancel this. That gave me 0.01 amperes. Do you understand? Okay, do you understand? All right. So the resistance of this galvanometer is 30 ohms. That is RG. Is 30 ohms. Okay. Now you cannot want to convert it to an ammeter. The current flowing in the circuit is 10 what? Amperes. Right? What are we looking for now? We are looking for the resistance. The resistance, that is resistance of the shunt. Sorry. We are looking for the current, the resistance of the shunt, and we don't even have the current of the shunt. For us to get the current of the shunt, we are going to say this is the total current minus the current of the galvanometer. From what I explained from that diagram, the total current is 10 minus current of the galvanometer, which is what? 0.01. Are we there? So we have this is what? 10 minus Let me do it here. This is 10 minus 0.01. That will give me 9.99. I don't know if I'm correct. Amperes. Please, am I correct? Am I correct? Okay. So the formula for this question is PD across shunt equals PD across galvanometer, or PD across galvanometer equals PD across shunt. So whichever way we choose to use it, or use it the right way, you're going to get the correct answer. Okay, so this is what? PD across shunt equals to PD across galvanometer, right? What is PD? Current times resistance. So this is IS RS is equal to what? IG RG. Are we cleared? So IX is equal to IG RG over IX. So let's just put in our values. What's my IG? 0.01, right? So this is 0.01 times resistance is 30 divided by what? 9.99. Are we there? Okay. Now, who can tell me the answer to this question? Of which, looking at it now, this cancels this, right? Cancels 1. So this can divide this to be 1. This can divide to be what? 3.33. Okay? So who will tell me the correct answer to this question? Are we solving? This was the correct answer to this particular question. Okay, 0.03 ohms. Okay? We have two options that has that answer. A and B, they have 0.03 ohms. So which particular one is the correct one? Which particular one is the correct one? We have 0.03 ohms series resistor. We have 0.03 ohms shunt resistor. Which particular option is correct? Shunt resistor. I hope you know why we are using shunt. You know why we are using shunt, okay? Okay? We are using shunt because this is what? We are converting from galvanometer to ammeter. We must use what? Shunt. Okay? All right. So the answer to this question, Rx is equal to 0.03, which is option what? B. We are choosing option B because it must be in what? It must be a shunt resistor connected in parallel, not in what? In series. Are we clear? Do we understand? Okay, Maruchi, okay, that's true. Do you understand? All right. So let's look another question. I hope you get it. Any question? All right, yeah, B is the answer, Lisa. Okay, any question, Maruchi? So let's go to the next example under this. Let's go to the next example under this. Let's see whether I'll give it to you to solve it for me. Okay, the same pattern of question but different way. All right, option B, that's correct. Okay, that's cool. So let's go to the next one. Antonia, is that Chidera Atan? Chidera Atan, is that you? All right. So okay, now this question. right, so let me list options. Option A, 19.80 ohms. Option B, 5.00 ohms. Option C, 0.05 ohms. Option D, 0.25 ohms. So we can look at this and attempt it. Let's see where you can get the answer. The same way I solved the first one, you can solve this. This question is gotten from 2006. This is gotten from 2006, number 23. Okay, please, you have few seconds, or let me say 2 minutes to solve and get the answer. Please solve this few seconds and give me the answer. All right, I have an answer, 0.05. That is option C. Okay, who else is solving? Option C, okay. Option C, 0.05. Okay, option C. So 3 people are going for option C. Okay, 4 people option C. All right, let's solve. Let's just solve for the sake of those people that have not attempted it or they don't know how to do it. All right, so let's solve this. Now the question says an ammeter of resistance 5 ohms. Once you hear the word ammeter, you're talking about what? Galvanometer. Okay, don't mind the English, that's how they used to write it. An ammeter of resistance 5 ohms. So that means resistance what? 5 ohms has a full scale deflection when a current of 50 milliamperes flows in it. So the current of the galvanometer is 50 milliamperes. We already know now what is 50 milliamperes. 50 divided by what? 100. That is 50 over 100. Sorry, 1000. So he gave us 0.05 amperes, right? The value of the resistance required to adapt to measure a current of 5 amperes. So the total current flowing in the circuit is 5 amperes, right? So how do we know the current flowing through the shunt? So I will say current of the shunt is equals to the total current minus current of the galvanometer, right? That is 0.05. Okay, that gave us 4.95 amperes. Are we clear? All right, so let's just put our formula. We now said what? ISRX is equals to IGRG. Now this one, you're looking for Rx, so this is IGRG over IX. Current of the galvanometer is what? 0.05 times resistance is what? 5 divided by 4.95. Okay, so the answer to this question is 0.05 ohms, because this is a low resistance wire. It's a low resistance wire. All right, so that is that. Any question? Any question? It's not C or B. Oh, it must be one. It's either it is this or this. It's not C or B. You can't tell us C or B. If you choose C or B, that means you're going to fail it now. Faye, Emina is divine. Okay, maybe I'll send it to their group next time. All right, so please, do you have any question? Let's go to galvanometer, conversion of galvanometer to a voltmeter. Sorry, hold on, please. Okay, sorry. We are back. Trying to put my power bank, but phone will go off. All right, we are good. So let's go to the second part of the topic, which is the conversion of galvanometer to a voltmeter. Quickly, let's explain it and we solve. By connecting a high resistance or multiplier in series with the galvanometer. Okay, so let me do a rough sketch of what I just explained. All right. So now look at this diagram. You can see the difference between this one and the previous one. Okay. Okay, they didn't give example of on if we are given the shunt. Okay. Let me search for it. All right. Okay, so I have a question on that. So after solving this one, we'll solve one or two problems. Then I'll bring that one up. Is that okay? All right. So let's just explain. Lots of time. Now, a galvanometer used for measuring a small current, very small current rather, can be converted to a voltmeter by connecting a high resistance or multiplier in series with the galvanometer. We can now see that the previous one we did, the galvanometer was converted in parallel with the shunt, okay, which is a low resistance wire. But now this is, we are converting it to a voltmeter, so we're using a high resistance wire called multiplier, and it must be in series. It must be in series. This is a high resistance wire. It must be in series. We call it what? Multiplier. We call it what? Multiplier. Now, for us to calculate the total PD across this circuit, now they are moving in series, okay? Unlike the previous one that was moving in parallel. So for us to get the total PD equals what? The PD across multiplier plus the PD across galvanometer. Total PD is equal to PD across multiplier plus PD across galvanometer. Is that okay? So what is this PD across multiplier? That is this. PD is current times resistance from Ohm's law, right? Okay, so I will say V is equals to IM RM plus IG RG. Now, something is important you must note, because the two of them, the galvanometer and the resistor, they are moving in series, okay? The same current flows. Any current that is being measured in the galvanometer is also measured in the shunt. So what am I trying to say? I'm trying to say that what? That IM equals what? IG. The current across multiplier is the same thing across what? Galvanometer. If the galvanometer measures 0.05 amperes, it's the same thing that flows through the what? Multiplier, because they are in what? In series. Please don't get confused. See what I just explained. Okay? If the same current is flowing in the galvanometer, it's going to still flow at the same value in the multiplier. Reason because they are moving in series, unlike the previous one that are moving in parallel. You can see the difference, so don't get confused. You understand? All right. So in this aspect now, you'll be given the total PD across the circuit, which is across the multiplier and the galvanometer. You'll be requested to get the resistance of the multiplier, which is a high resistance value, which must be in series. So the value of the resistance of the multiplier is always very high. All right. So I have a question on that. So guys, let's solve. Please, do I have question before I proceed? Any question? Any question, please? All right. When I should explain. Okay, let me explain. I've explained it again, but let me explain it again. All right. I said in this one, a galvanometer that is used for measuring very small currents, we can now use it to convert, to start making use of what? Voltmeter. How? By using a high resistance wire or multiplier. It must be in series. You know why I'm underlining all these things? Because JAMB will ask you as a theoretical question, okay? All right, so see the diagram. Look at see the multiplier, see the galvanometer. They are connected in what? Series. So if they are connected in series, the same current flows. Any current that flows through the galvanometer also flows this in what? In the multiplier. Also, looking at the PD, the total PD equals what? The PD across multiplier plus the PD across what? Galvanometer. Is that okay? So the total PD is equals to Vm plus what? Vg. What is V? From Ohm's law, V is equals to what? IR, right? If V is equals to IR, so the V, which is PD across multiply, is equals to IMRM, right? So VG is equals to what? IGRG. Is that clear? Obonna, are you okay now? Should we proceed? Should we proceed? All right. So let's solve question. Let's solve question. All right, so let me write all the options provided. Option A is 1750 amperes. Sorry, ohms. Option B, 1950 ohms. Option C, 2000 ohms. Option D, 2500 ohms. So guys, look at this question now. Look at this question. I hope the board is clear enough. All right. Do somebody understand this question at all? Do somebody understand this question at all? Do we understand? I want to start solving it. Any question? Okay. Okay, so Chidera, lessons, I'm going to be explaining it with this question now. Let me just solve it. Okay, so let's solve it. A galvanometer of internal resistance 50 ohms. So the resistance of the galvanometer is 50 ohms. right? Okay, has a full-scale deflection for a current of 5 milliamperes. Now, the current of the galvanometer is 5 milliamperes. We all know once you see milli what it means. We must convert, okay? You must change. So this is 5 over 1000, which is 0.005 amperes. Okay, what is the resistance required to convert to a voltmeter with a full scale deflection of 10 volts? So the PD in the circuit is 10 volt, right? But you must note that in this context, the same current that flows through the galvanometer flows through the multiplier. So I will say that IM is equals to what? 0.005 amperes. Okay, we are looking for the resistance of the multiplier. All right, so we're going to use our formula, which is V is equals to what? VM plus VG, right? V is equals to IMRM plus IGRG. Hope that is clear. So let's put in our values. What's my V? My V is what? 10. 10 is equals to my IM is 0.005 RM plus. Please, do we have question before I proceed? Oh, I've gotten an answer already. All right, option B, that's cool. So let's proceed. Then the current here is 0.005 times the resistance is what? 50. Okay, so let's go. This is 10 is equals to 0.005 RM plus, when I multiply, I'm going to have 0.25. Please, am I correct? All right, so I will take this one to the other side. That is 10 minus 0.25 is equals to 0.005 RM. Okay, all right, so this is going to give me 9.75 is equals to 0.005 RM, right? So therefore, by the time I divide, my RM is equals to 1950 ohms, which is option what? B, right? Are we cleared? Lisa, I should come again. Okay, let me explain again. A galvanometer of internal resistance 50 ohms, that is RG equals 50 ohms, has a full-scale deflection for a current of 5 milliamperes. That is, current of the galvanometer is 5 milliamperes. We all know what milli means. Milli means what? You divide it by 1000, whatever value given to you. So that is 5 divided by 1000, okay? That gave rise to 0.005 amperes. Now, okay, the question says again, what is the resistance required to convert to a voltmeter with a full-scale deflection of 10 volts? So the total PD across this circuit is 10 volts, right? And remember, because they are connected in series, the same current flows. The current that flows through the galvanometer flows through the multiplier. So that is why I have IM to be 0.005 amperes. Okay, all right, so we're looking for the resistance of the multiplier. From the formula, the PD, because they're connected in series, the PD equals what? VM plus VG, right? So my V equals what? IMRM plus IGRG. Okay, all right, so we put in our values, the values that we have. So my V equals what? 10, right? My IM is 0.005 multiplied by RM, right? Then plus my IG is what? 0.005 multiplied by what? Resistance of the galvanometer, which is what? 50. So we just work it out. We have this is 10 equals this one, plus we multiply to have 0.25. Collection of like terms, okay? So that is 10 minus 0.25, which gave rise to 9.75 equals 0.005 RM, okay? So that gave our answer to be 1950. Are we cleared? All right, so that made option B to be the correct answer. Lisa, are you okay? Is it cleared? Is it cleared? All right. This class is meant to be 1 hour. Okay, that's cool. Meant to be 1 hour class. So I'm going to drop. Make sure you solve all the assignments given, and please, to give you edge to go to your past question. I'm using pre 50. Go to your past questions. Any topic we discuss, just go to the past question. Anyone cannot solve everything because of limited time. Go there and solve as much as you can. If you have question, please ask me the question in our group in WhatsApp. Okay. All right, the WhatsApp group. Don't forget. So let me drop an assignment for you. Maybe I'll drop two, one for voltmeter and one for ammeter. All right. So assignment time. All right, so we have these following questions. Try and attempt it and make sure you drop your answer in the comment section. All right. Bright, please, what's your name, please? Bright, what's your name? Let me know who is asking the question. Bright, what's your name, please? I don't know what is wrong with my camera. Please, let's manage it. Bright, what's your name? Elijah, okay. Equilibrium of forces, okay. I've done that before, but let's see how it goes. I have a lot of topics I need to touch before I go back, okay. Let's see how it goes. Please, tomorrow is Saturday. Tomorrow, Saturday and Sunday, our classes will be by 6, please. Okay. Our classes will be by 6. We start by 6. Is that okay? Other days will be by 4. Okay, our classes will be by 6 to 7. Is that okay? All right, so make sure you do your assignments. Make sure you read your books. Very, very important. There's no time to sleep. No much time again. So let's see what we can achieve before 1 week time, so we can start revision proper. Celebrity, any question? All right. Maruchi, you know your friends have not yet joined us. Okay. Tomorrow, meeting by 6, please don't forget. Maruchi, you know your friend have not yet joined. Please let them know that we have started online. Elijah, have you subscribed to my channel? All right, you're welcome. Elijah, have you subscribed to the channel? Have you? Six p.m. tomorrow, please. 6 p.m. Tomorrow and Sunday, 6 p.m. All right. Chidera, I hope you understood everything we did today. Go and read your book. Oh. Do the assignment. I want to see your answer. Chidera, did you hear me? All right. See you guys tomorrow. Have a good night. Maruchi, Sunday, Saturday and Sunday is by 6, okay? All right. So I'm ending the live now. Oh, you scored 280 last year. Oh, okay. By God's grace, you have what your heart desires. By God's grace, let's work towards that. Okay, you're one of my students. You had classes last year. Is that right? No problem. So let's continue. Okay, no problem.